All right, so let's start looking at web things. And a lot of the web is just creating a template which will be personalized for the user. And so what does that mean? So when you look at websites like, I don't know, what's a website where I'm logged in at that I want to show? I don't think I'm logged in at Facebook. Hey, I am. Cool. So this is a template. My mouse gets all squirrely when I have a HDMI plugged in because they're really close. This is a template, right, that gets customized for me. And so what that means is, like, here's like my feed, right, of like things that are going on with people I know. And so when I come to this page, it shows me information about people I know. When you come to that page, it shows you information about people you know. So that's like the biggest part of web programming, probably, having a template and filling it in with data unique to one user. So a common way that we see templates in the real world is with junk mail. And so, you know, this might be a letter that goes out to everybody I know, but then it gets personalized. And so I'd write this one letter, and then I'd have a database or some sort of data storage with data in it, and then I would just merge for each record in the data, merge in the name, right? So this is mail merge. It's a template, you know? So this is just an example of a template. And so it's like this for a web page too, right? We just create a web page, and then we tell it to merge in data, you know, for different places in the web page. Like the news feed, merge in the data that is, you know, unique to me. So here I have index.html. Let me do this one actually. I opened the wrong one. So all of your Go files will have a .go extension. So those will be your Go files. We are working at the Golang playground. And when we set up our environments, right, and we create files, your files will have a .go extension. And so here's my package main. And I'm using the func package. And then here's my func main, which is the entry point for my program. And between these curly braces, here's the code. I'm declaring a variable, setting it equal to a string. And I'm just printing. And by the way, you could use double quotes to say this is a string, or you could use backticks. On the keyboard, your backtick is in the top left area, under a tilde, near the escape key or the tab key. Do you guys see that little backtick under the tilde? So here I'm using backticks to print a string. So that's another way I could print a string. And it's going to maintain the layout when I print with backticks. And so my string goes from there to here. And then again, my string goes from here to there. I'm just trying to get multiple cursor insertions, not doing it. And then in between, I'm concatenating my variable name with that string. And so I could go to my terminal. I just went there. There we go. And change directories. And so CD, and I'll teach you how to work at the terminal when we get to this, you know, changes directories. And I'm just going into my Go workspace, source, GitHub. This is just my folder structure. And then I'm going into the Golang training, Golang Web. I want Golang-web, Golang-web. And I am in 003, and I'm in 01. And if I look what's in there, there's my main. I'm going to remove index.html, so yeah, that's what I wanted to remove. Remove index.html. I thought that did it. What do I have to do? Type yes? There we go. Go run main. And I'm going to take that output, because right now the only thing that's in this folder is main.go, right? So now I'm going to go run main, and this is just terminal commands, so this isn't Go stuff, but I just want to demonstrate templates here. I'm going to dump that into some file.html. So I could call that index.html, but I just want to show that this is different. And so now when I look, so it's booting up Go. That always takes a second the first time. But now when I look in my folder, I have some file.html. And I could come here and I could look. And some file.html. I could reveal this in Finder. Reveal in Finder. And I could open this in my browser. And I've created a web page. So just merged in the HTML text with some data and told it to dump that into a file and created a web page. I think that's kind of cool, right, as a starting point. Anybody have any thoughts on it? No thoughts. Okay. So I could also do this. I could take from package OS and I could create package OS, lets you do operating system stuff. I could create index.html. And when I do that, if I look at OS create is going to return two things. It's going to return a pointer to a file and an error. Okay? So when I call OS create, and this is just to demonstrate the point again, but instead of me saying dump this into a file using Unix commands, I'm going to have it create a file. And so I'm checking if the error is not nil. I'm going to log fatal. There's an error creating that file. And then whenever you open a file, you have to close it. So in Go, we could do defer, which means when I exit this function, the last thing I'm going to do is I'm going to close everything that was, I'm going to run everything that was deferred. And so this allows you in your code to closely associate the creation or the opening of a file with the closing of a file. So it's really readable, it's much more maintainable, it's much less prone to forgetting to close something that you opened. Because imagine if you just kept opening files, you had a program that did this, and files kept being opened but never closed, that's going to eat up your memory and eventually cause your machine to crash. Right? So you got to close all those files that you open. And then I'm going to use from the package IO, input output, a function copy. And I'm going to copy this string to the new file. So that's some pretty crazy code right there. Like that's a big jump for you guys. We just went from like how do you declare a variable, how do you create a function, to like, whoa, all these different packages. So the main thing is just this is a demonstration. And what you should be seeing here is like just learning the language. Oh, this is the package. Cool. And this is a function in the package. Okay. Right? We saw that. We saw fumped print. Right? We were using print line before. Here's string print. Right? We were using print line, which prints to standard out. Here's string print, which prints, just basically creates a string. It's like print, but instead of sending it to standard out, it just creates a string, and then I could store that to a variable. If we look at fumped sprint, right, it returns a string. Cool. A string was returned. Here's func sprint, just like print, right? Func print took interface and returned an int and an error, which we didn't do anything with. You don't have to, I guess, in Go. It doesn't throw an error, right? And and here I'm doing sprint, which gives me a string back. So I'm catching that string. I got to go up here. And storing it in a variable. I'm catching the value, and I'm storing it in a variable string, str, right? And then with str down here, I'm using str. And this is from package, so you should be taking, hey, this is package strings. There's a package strings. And I could read that string, right? And then I could write it to the file. How many people totally follow that? How many people are like, yeah. So package, function, package, function, package, function, package, function. Right? If I go and I look at GoDoc, you tell me, where do I go to look at and want to type it. Where do I go to look at a package? Look a package up. What website? Google. Godoc.org. So let's look up. We have, I don't know, you choose one. I can't choose apparently. What do you want to see? OS create. So package OS. Here's package OS from the standard library. Package OS provides a platform for operating system functionality. Design is Unix-like, right? All the error handling is Go-like. OS open file.go. I could open it. Gives me a file and an error. All right, check the error. All right. Here's the index. So open was one of them. Ours was create. When I run create, OS create, I'm looking here. So here's type file, and there's func create. Interesting, it's under type file, it's func create, but I just call it OS create. That's how I call it. I give it a name, it gives me a pointer to a file. Well, I said that when we have a variable, we are going to have, we will have, well, I have 62 messages on Facebook. I never go to Facebook. And my mouse doesn't work with the HDMI cable plugged in. When I have a variable, I'm going to have, or when I have a function, if there's a receiver, it'll be right here, some receiver, and then the identifier, and then the params, and then the returns, and then the code, right? That's the way a function is. And I said, hey, this is how you do methods with the receiver. So here I get back a pointer to a file, and then here we have func, and this is a receiver. And there's the identifier. So these are all methods which are attached to the type pointer to a file. So when I have a pointer to a file, I could close it. Well, hell, a file needs to be closed, so that's something I need to do with my pointer to a file. So over here in my code, right, I get a file, pointer to file, I assign it to nf, new file. Now nf has this method close attached to it, which I could then call on it. So defer close that file, right? How many people are sticking with me? How many people are like, okay, I'm kind of getting it? So let's say we go and we look at IO copy. So I could go to the documentation at GoDoc, and I could type in IO, and I could come to package IO, I could go to the index, and I could read, okay, there's copy, and it takes a variable called DST, it could be anything, and it's of type writer, and it takes another one, SRC, which is of type reader, and then it returns these, right? Well, what's a writer and a reader? Like, don't overthink this stuff. A writer is anything that could be written to. A reader is anything that could be read. Can a string be read? It could be read, right? Can a file be written to? It could be written to. Hell yeah, I could write to a file, right? Like, just at the most basic level, just thinking logically. So I'm going to write, takes a writer, right? Copy, takes a writer, reads from someplace, and it writes to someplace. So I'm going to read from this place and write to that place. Well, why did I have to wrap the string? If a string could be read, why did I have to wrap it in new reader? That's a little bit more nuanced. But that's how I made the string a reader. Implement the reader interface. So interfaces define functionality. Yeah, that's a big jump. But that's just like a little bit of an example, and this stuff will start to click. So here's one more program. So I could use from package OS, and I could ask for args from the command line. What are args? It's a slice. and they're strings, right? Var args from package OS. Hold the command line arguments starting with the program name. So the program name is the first one. It's all the command line arguments. And so here I'm calling it, and I'm saying args1. And I could print out 0 and 1 here to see what those are. And if there was another one, I could do that. And so now I'm assigning what's in position 1 to name. So when I run this program, main.go is the name of the program, right? But now I also need to pass in some string. And I want to make sure it's asking for 1 and 0. That's it. So now when I run this, it gave me the first arg in position 0, which is that, main.go, the path to main.go, and then it gave me, printed out the second one, and it created index.html, which now has that. So this isn't like, you know, a lot of other, I don't know, like, you know, this is like just thinking about creating the web with programming, and how do we start thinking about creating the web with programming? Merging variables with strings, putting them into an HTML file, and then serving that HTML file, right? Being able to use templates. So just demonstrating some of the stuff here. And so instead of you know, just having a string and then dumping it to an HTML file, we could actually create templates. And so you could call these any extension you want. It could be any extension you want. Go.html is the customary one. You could call it PHP, ASP, CFM. Confuse the hell out of people when if they ever got into your server. Right? You could serve them up at .php, whatever, it doesn't matter, because you're going to customize everything. Right? So when a request comes in at a certain route, you know, it could be like, you know, index.php ASP CFM. You could have that for an extension. People will be like, what? And it'll serve, because it's totally RESTful. So this is a template. So we create a file that's a template. So here's my template. Right? I didn't merge any variables in there. I didn't pass any variables in. It's just HTML. Hang with me, Faisal. Just a tour here, baby. And then I'm going to use some functionality, right? Low-level systems level language with a standard library that offers a lot of high-level functionality. And I'm going to use from package template. So we have text template here, right? Is the package. But when a package has, you know, 2 parts to it, you only use the last part. So text/template. We're just using template. Package template. You can see my editor's highlighting that for me. Parse files. Parse files is basically like, hey, open this up and take a look at it and store whatever's in there in the variable template. And I'm going to execute that and execute it to standard out, which is my terminal. And I'm not passing in any data. And so we're just learning how to use the different pieces of code which are already written for us so that we can build cool web pages. And you saw how to declare variables. You saw how to create functions. You saw that, okay, when I call a function, it's the package and then the function. Well, now I'm going to introduce you to a bunch of pre-written code. Once you learn how to use these different little pieces, right, you're going to be able to like build web pages. In the Go way, the fastest way on earth at this time, twice as fast as Node.js. I like to say, though that's undocumented. I read it somewhere once. Somebody did some benchmarks. It goes on average twice as fast as Node. So Node would be your second choice if you didn't have Go for speed. And so now with this file, right? So I'm in 00401. Right? It opened that up and printed it to standard out. So I had a text file, an HTML file, whatever. It's text. That's all HTML is. Text with certain formatting. I had that in another file. I told the program, go get that and open it and then write it to standard out. And I used these functions to do it. From template package, the parse files function. Parse that file. Right? And parse files is going to return like a pointer to a template or something and an error. A pointer to a template gives me back a pointer to a template. Must, I'm at this one. Gives me a pointer to a template and an error. Right? Parse files. Cool. What's a pointer to a template and what can I do with it? Well, heck, let's go look at text template at godoc.org. Text template. And by the way, the URL up here is also RESTful, so whatever package I want, I just enter the name, right? Package funct, gives me package funct. Package OS, gives me package OS. Package text template, gives me package text template. Why is it text template? Why isn't it just template, Todd? Well, because guess what? Text template lets you do templating with text. And then there's HTML template, which is built on top of text template and does everything text template does, but also with cool HTML functionality built in to escape things and avoid cross-site scripting attacks and things like that, which is what you want with your templates. But right now, we're just starting with text template, right? And if I go and I look at text template, tells me all about using templates, and that's a big chunk, right? But when I do parse files, I give it the file names. We know that this is a variadic parameter. It'll take as many strings as I want to enter. This file name, this file name, this file name, as many as I want to enter. Parse all those files, and it'll store them all into a pointer to a template. That's like a bucket. And it's just like a bucket in like the sense of a bucket like you got in your backyard, collecting no rainwater in this desert of a town. Right? It's just it's a container, your pointer to a template. So I parse all my HTML files into my pointer to a template bucket. And then func, receiver, identifier, parameters if there are any, right? Func, receiver, identifier, parameters, returns. Func, receiver, identifier, parameters, returns. Right? So these are all methods attached to a pointer to a template. So when I parse files, I have a pointer to a template. My pointer to a template now has all of these methods that I could call on. I always look to see if there's a close. Because if there's a close, I'm going to have to defer that and close that so that when I leave this function, whatever I open gets closed. There's no close there, so cool, I don't have to close anything. Right? But sweet, I got all those methods. Execute is one of them. Execute template. And it's like a writer and a string and a data interface. Execute's a writer and a data interface. So execute's just going to execute, like if I only have one of them in my bucket, it'll execute that one. If I have multiple of them in my bucket, it executes the first one. Right? Execute template, if I have multiple in my little pointer to a template bucket, I say execute this one, I give it the name. Execute this template, I give it the name. I fill my bucket up at one point in my code with parse files right here. I've got my bucket of pointer to templates full of my templates. And then later I'm like, oh dang, snap, I need to parse another file into there. I've got a method here, parse, right, or parse files, and I can pass in another file name, and it gives me back another pointer to a template. It just added another HTML chunk of code template to my bucket full of templates, right? My pointer to a template bucket. So that's the difference between parse files up here and parse files down here. This gets called from the package level, so it's going to be template.parseFiles. This gets called from whatever identifier I assigned to it when I first got this. It's not that complicated. It takes a little second to wrap your head around. Wrap your head around it with me. You ready? We create templates. The web is all about templates. And we just call them TPL, Go HTML. This is just HTML. That's it. And we build our website with a whole bunch of HTML pages. But now they're Go HTML. Right? And then we say, okay, put all those into a bucket. And so template from package template, parse those files, and we list all those file names. If I had more here, I'd just list them. Huh? Slice, not arrays. Arrays underline slices in Go, and that's for performance. So we don't really use arrays. We use slices. They're like lists in Python, right? And so you could slice slices, and you know.
Isn't that still essentially an array?
Yeah, just think of it like an array. But I need to make the distinction so I don't teach you wrong. So later you're like, dude, I thought you said it was an array. No, it's a slice. It's built on top of an array. We don't really touch arrays because that's all handled by Go. We use slices, and there's aspects of them which are more performant than arrays. And that's all like who cares? Let's just make stuff. And we just need to know to use slices. And I don't mean to be loud and shut you down. I'm just trying to be engaging. Oh, yeah, so if I ever get a little loud. So template, Gma, I could do like, about.php, right? And if I have a file called about.php, it's going to parse it. It doesn't care. Call it whatever I want. But I'm going to stick with like Go HTML. And then it'd parse all those. And then here I'm just saying execute, right? So it'd execute it. I could also do execute template. And there I got a little code completion, right? And so I think if I don't know how you do that. Here it wants the writer, the name, and the data. So here I'm giving it the writer, write it to standard out, and then I'm going to give it the name. And so here I type in tpl.gohtml, and it'll do that one because in my bucket I got a thing that's been parsed into it called tpl.gohtml, and this will give me the same output. All right, cool. But I'm going to leave it just execute template. So if I had multiple, I'll just execute my first one in my bucket. So the cool thing is, right, here's another file. And parse files, create a file, close, execute that template, and write it to that new file. In the previous example, I wrote it. Oops, wrong one. In the previous example, I said, hey, just execute it to standard out. Template execute standard out. In this example, template execute to a file. I could write to standard out. I could write to a file. Polymorphism. Same function, right? Same function, but it could receive really different arguments. Those arguments both implement something known as the writer interface because they have a method that when you have that method, you implicitly implement this interface. You never explicitly have to say implements writer interface like in Java, right? It just implicitly implements it. And then if something implements the writer interface where a writer is asked for, you give it a writer. So it is both whatever type it is, an int, a string, whatever, if it also has a method attached to it, which makes it implement the writer interface, then anywhere a writer is asked for, you can pass that data in. That's the complex definition. That'll make sense by week 4, right? So don't worry about it. I'm just going to say that many times the first couple of weeks, and eventually you're going to, oh, I get it. Took me a while to wrap my head around interfaces. But here, the main thing is, man, I could tell to write to standard out, and it dumped my contents to standard out. Or I could tell to write to a file, and it will dump my contents to the file. Just created index.html. Sweet. Or, guess what else template execute can write to? It could write to a file. It could write to standard out. It could also write from a server's, it could write the server's response to the client. I could write to that response. Send that file to the client. Execute it. And instead of sending it to standard out or to a file, it's my response. That's the server's response. Right to it. Whoa, sweet. I love it. I write my HTML. I just grab this code here, which is already written for me, and I say, parse all my HTML files, put them into a bucket that's holding them all, and then I just execute it. And if I need to specify exactly which one is executed, I use execute template, and I pass in the name of it. And then when we eventually learn how to set up a server, I just say, don't write to standard out, write to my response, right? Write to my response, my server's response. Off to the client. Wow! You're building web pages. HTML, CSS, a little templating. You guys tired of that one yet? It's cool. It's fast. All right, well, that's cool. That's fast, right? Here I called him, instead of GoHTML, I called him GMAO. And this just demonstrates parsing files, right? And then I got TPL. And remember I said you could parse it from the package level, template parse files. That was this one. Template parse files right there. But hey, what the heck? There's another parse files. This one's package level. This one is a method attached to anything which is a pointer to a template. Don't worry if you don't know what pointers are. Not necessary for creating websites. Eventually, you're going to figure that out. When your website's going great, you're like, I got to figure this pointer stuff out just so I know it. But yeah, okay. What's the difference? Method, this is the package level. This one is the variable value level, right? So here that's demonstrated. Package level parse files gives me a TPL, which is of type pointer to a template, right? Because parse files gives me a pointer to a template. So this is a variable TPL of type pointer to a template. I have that TPL, and then from TPL, I call parse files. Totally different function, right? This one is one function. This one's a different function. This is the one at the package level. This one's attached to a value of type pointer to a template. And this parse files just adds more files into my little template bucket. Cool, I got more files in my template bucket. I could put files into my template bucket the first time with parse files from the package level, put them into my template bucket. I put in one GMO. Whoops, I forgot 2 of them. From that value of type pointer to template, which this gave me, I can now call a method attached to anything of type pointer to a template, and I could pass in a variadic number of arguments, which are of type string, and add those to my bucket. In my bucket, I can now execute any one of those. Template, execute template. I'm specifying it. This is code that's already written for us. We don't have to understand what's going on in the background. We don't have to understand all of the nuances and all of the amazing beauty and performance and optimization of the Go programming language. All of the internals, we don't have to understand it. All we have to understand is like, sweet, this is how I use this stuff. Hillbillies can write this stuff. There's like we've looked at like a handful of functions so far. Right? And I'm just checking my error. If my error is not nil. If it's not nil, that's kind of weird if you've never heard that before. So if something's not nil, that means it exists. I am not nil. I exist. If I was nil, right, like I got vaporized. Oh, Todd's nil. He's not there. If I'm not nil, I exist. If the error exists, that's what that says. If the error is not nil, stop the program. Log, fatal line. We're going to log this error and stop the program. Something happened. So that's just error handling. And it's weird, you got to write that every time. But handle your errors. Don't like do try catch bullcrap at some point way down in your code. Do something, and if it doesn't work, handle the error. Like no right there, right then. Open a file and defer the close. That's how you write clean code. Right? You opened it and you deferred the close. It's right next to each other. You didn't have to scroll down 20 lines to see if you actually closed that file. It's right there. Right? It's well-designed language. This is not built by idiots. It was built by geniuses. Go is a genius-level language. People kvetch about this. I'm like, have you ever done try-catch? I hate try-catch. So that's cool. That would totally run. I'm not going to run it. So I don't want to.
So
yeah, let's hear it.
That Go doc, you could learn what the fatal line does.
Yeah, fatal line is fatal, man. What's fatal? It kills it. It kills your program. It logs.
Kills it?
So we could go to GoDoc. Let's do it. And instead of like searching up here for log, we now know that we could just do this. And package log tells me what package log does. And here's fatal line. I could click on it. And fatal line is equivalent to print line followed by call to OSX@1, which basically means stop this program.
Is it writing a log to a file? Or?
And it writes a log to a file. And with log, we can set output to any writer. Anything that we write to, we could just log anytime there's an error. That could be a text file on the server. That could be an SMS message that goes to my phone. Every time my server screws up, it just logs the message straight to my phone. I could log to both. File on the server and text me.
You push a status to Facebook.
Push the status, log it to Facebook. I could tweet it. Now, granted, the SMS and the tweeting and Facebook, that'd be a lot more work. I haven't done logging to SMS. I don't know if there's an SMS package, but we could search SMS. SMS worker, right? So web, queue, SMS. Enables arbitrary SMS providers. Twilio, using Twilio. Cool, I know Twilio. Let's do some Twilio. I did some Twilio with Python. So I'd get that third-party package somebody else wrote, make sure that there's no code in there that's going to give them backdoor access to my server, because somebody else wrote it, right? And then use it. Mostly you'll probably be fine. But look through it, because some people are out there going, ha, ha, ha. Like, how's the NSA get hacked, right? You guys read that today?
So that the right to the writer, you have to set that up if it's not right there.
Yeah, yeah. You could specify your output, but I didn't do that here.
So what's that exactly doing? Just killing the program?
Yep, log fatal kills the program, logs it and stops it. You could also do other logs, right? Like if we want to look at that, what other logs there aren't necessarily fatal. You could log panic, you could log print, right? So what's the difference between fatal and panic? You could go read that. You could print. So you could just log and print it and then SMS you and keep running.
Just ignore it. Just send me a message and ignore it.
So I get tired of typing in all my file names. Parse files. I got 30 pages on this website. I'm going to be here a while. So I could parse a glob. What is a glob, right? Instead of parsing a file and listing all the file names, I could parse a glob. And I could say, hey, parse everything in this folder that has whatever name followed by this extension. So that's like, you know, the wildcard, anything followed by this extension. And so it will parse all of the files in my template folder. And I could have one or I could have 10 million, and it'll do it all and it won't complain. And so if I execute these, I don't know what this program does. Executes its template to standard out. So we'll execute 04. Because in here, all I have is 1, 2. Yeah, it could be anything, HTML or just whatever text. So that's parse glob. Okay? So all I'm doing is like showing you like, hey, look at how these little Lego pieces work. And then you're going to take it and you're going to build stuff. You already know HTML, you already know CMS. Great, I now have a program that can open it all, read it, and execute it and write it wherever I want. Whether it's a file or standard out or a server response. And now I've wrapped template parse glob, because before I had just parse glob and then I checked the error, right? Now I'm using template must and I wrap that. It's a wrapper. What do you call that, Ken? Do you know? It's a wrapper function.
Yeah.
I'm just wrapping another function. But template must, what is template must? So we'll go to GoDoc and go to text HTML. Or text template, sorry. Come down to my index. And so parse files gives me a pointer to a template. Parse glob gives me a pointer to a template. Sweet, I know what the pointer to a template is. It's a bucket where all my templates got put in. And then I have must, right? Which must is like it takes a pointer to a template and an error. Well, when I do parse glob, I get a pointer to a template and an error. Look at that. Just trying to get that to, oh, because, okay. So it takes a, let me undo that. Dang it, I got to come up here. Takes a pointer to a template and an error, right? Or that's parse glob or parse files, gives me a pointer to a template and an error. And this one wants a pointer to a template and an error. So I could take parse files or parse glob and stick it right here. And when I run it, it's going to give me those two things back, which is what must wants. And must just gives me a pointer to a template. So I no longer have to check for the error, because what must does is it must happen. It's a helper function that wraps a call to a function returning a pointer to a template and an error, because that's what it takes. And it panics if the error is non-nil, is intended for use in variable initialization such as template must, template new name, parse text, right? Which is basically like, just parse a glob or parse your files. So it's just like a little way to avoid error checking. It's like a little cleaner code. It gives me my pointer to bucket. And I did it in a different function here. What's that function? Func-init. Init is a special function that runs when your program initializes. Every time somebody comes to my server, I don't want to have to parse all my files. When I first fire up my server, parse them all. Have them ready to go. Do it once. They're all in this variable. Now use that variable over and over. And because that variable needs to be accessed by different functions, I'm going to put it at the package level.
So if init gets automatically called then?
Automatically called when your program fires up before main. Yeah. Because you don't want every time somebody comes and says, let me go to the server, oh, let's parse all the files. Let's parse all the files every time somebody comes to your home page. You just want to parse all the files once in init, put it in that variable, which is in the package level scope, which can now be accessed both also in main. That's the code. Well, that's cool, Todd, but you haven't passed any data in yet. But check that out. Nil, nil, nil. That's where you pass the data in. And you could access the data and do whatever you want with it. Like, so easy. God, it's so easy. All I got to do is copy this line and put all of my templates right here. Right? All my HTML stuff. I copy that line. I have this line here. And then I just execute whatever one I want. And, and I pass in data. Okay, that's like great. That's elegant. That's easy. And it has, instead of text template, it has HTML template. So everything will be escaped and cross-site scripting safe. Because it was built by geniuses. Well, I don't know. Do you think we really want Go? Maybe we should do like Python, because Python is written by Guido, and I don't know. I mean, he's into Monty Python. It's got a funny name. Maybe we should do Python. Yeah, Guido or Rob Pike, Ken Thompson, Robert Gressimer. You choose. Guido, who works for I don't know who, or Google. You choose. What about Node? Yeah, because JavaScript's fun. Loosey-goosey, no static typing. Yeah, let's do Node. Well, you use JavaScript on the front end and the back end. Yeah, but you shouldn't. Like, JavaScript is not performant. It's like they're getting rid of JavaScript. AMP pages, no JavaScript. Like, don't use JavaScript. Slow stuff down. I don't know. Soapbox. Is this the best choice? I have a Pentecostal grandfather. I don't know if you could tell. So here, we've seen this. Declare a variable. I am declaring that the variable TPL is of type pointer to a template. From this confused me when I first started. I'm all, template. From package template, type template. If we go and we look at package template, there is a type template. That's what we're referring to. And template is a representation of a parse template. The pointer to parse tree field is exported only for use by HTML template. It should be treated as unexported by all other clients. Okay. Whatever. So now I declare my bucket to hold my templates. I parse my templates into the bucket, and I don't have to check the error because I'm using template must, which says this happens or the program stops. So this init happens when my program fires up just once, so it parses everything, it's got it, it's ready to go. And then I run my main and I execute the template, OS standard out, right? And what is my template? All this and the meaning of life, and here's my templating. Between curly braces, I put a dot, and whatever payload I passed into that package, the dot is the front of the pipeline that accesses that piece of data. So curly braces like that, common templating. How many people have seen that in Mustache or Angular or something? Angular uses curly braces like that. So yeah, similar notation. So I run this one, and this is in 05. Meaning of life is 42. I passed data to my template and executed it. We're building web pages. And they're going to be fast at Google level, and we're going to host them on Google Cloud and use all of Google's infrastructure. Same infrastructure for Google, right? We're going to be performant. We need to store data. We need to store video. No problem. Suck that video up. Gigabytes. 2 cents a month for a gigabyte. No problem. 2.6 cents. Here I'm passing in a slice. Might call it an array. That's a slice of string. That's how you do it. Passing in Gandhi, MLK, Buddha, Jesus, Muhammad. It's a data structure for holding a list of things. So template, parse my files, has to happen, must. Get my thing, execute it to standard out, pass in all that data. What's my code look like? I'm going to range over that data I passed in, which is loop over it. And pipeline, the idea of pipeline is a very Unix thing where the output of one thing becomes the input of another. Right? Does that make sense? So the output of when I range over the data structure I passed in, that's the payload, the initial data chunk I passed in, which is a slice of string. I'm now going to loop over that, which will give me each individual string. So that becomes the next payload, right? Or the next piece of current data. So it's pipelining. The output of this becomes the input of that. I don't know if that makes sense. 006. That's looking like a web page. How many people are impressed by Go? Let me see your hands. Put them up. What? Nathan? Nothing?
Just like PHP or Go at this point.
Okay. I think it's pretty lean and pretty clean. And you could do other things. Range, this stuff, and if there are no items, just print out no items. So you could do a range else end. Right? And so we could see what data gets passed in, nothing. Could have also just passed in nil. Passed in an empty string. So I could start doing composition. So composition is kind of what we talk about as hell is composition? It's been a while since I've thought about that. So I'm not going to say anything. But Bill Kennedy has a good article on it. I want to say it's like how we talk about object-oriented. We talk about composition. Composition, go and go, composition with go, there we go. Yeah, it's all about structs and methods. All right, so here I've created a struct. So a struct is just a aggregate data type. It aggregates together other data types. So I have a string and I have an int that have been aggregated together in a different data structure, which is a struct. So it's a type, right? Type person struct has a field called name of type string and a field called age of type int. I've created a type. I've created my own type. It's person. There in my program, there are types that are like an int, they're a string, there could be a slice, there could be a map, and there could also be a person. It's a type. Well, that's trippy. Kind of a different way to think about things, right? And then down here, I'm creating a variable of type person. This is a struct literal. So I say the type and then the curly braces and I populate the fields and there it is. And now I could pass in P1 to my template when I execute it. And I could access my data like this. The current data structure and the field, name and age. Name, age, if license to kill, else, end, if else. So now what's my struct going to look like? It'll have name and age and probably a bool. Name, age, 00. Oh, this is interesting. Right? So instead of under person putting license to kill under person as another field, I could have just done it like this and gotten rid of this, right? That's what we've seen. Here's a more composition-y way to do it. So there's type person, there's type 00. Type 00 has everything that person has, and it's got a field called license to kill. So this is a promotion. Everything that's in person gets promoted to 00 so long as 00 doesn't have a field which conflicts in name with what's in person. In which case, you have to use down the line dot notation. So then I could create a type 00 and populate it with my person stuff and then populate it with my license to kill. The person field is this. The license to kill is that, so to speak. And then pass in my P1 and it executes. And then composition can get even more. Course, semester, year. So this is like a school, right? So every year we'll have a fall, summer, spring, and summer semester. Each semester will have a term, which is the name of the semester, and a slice of courses, right? Or a slice of course, which is just like a bunch of different courses. And each course will have a number, name, and units. And so then we just pass in, here's our year where we populate it. And we pass in our year, right? and we have the fall, right? So the year is fall, spring, and summer. So here's year, there's the fall field, there's the spring field, and I didn't do summer. And that is their semester. So here's my semester struct literal. From there, well, I don't want to move it. From there to there. And every semester has a term and courses. So here's my term, it's fall, and my courses are a slice of course. So here's my slice of course. And every slice of course has a number, name, and units. Every course has a number, name, and units. So here's my number, name, and units string. So here's each of my structs for that. It's a course, typed course, struct, number, name, and then units. So I pass all that in, and it's 0, 10. Or I dump it all to, and eventually we'll just serve it. Boop, boop, boop. So that's a lot. But you've seen that you could declare variables with Go. With the shorthand, the short declaration operator. I always want to call it shorthand. Short declaration operator, colon equals. It can only be used inside functions, right? The colon equal operator. You guys with me? Colon equal. And we saw that when declaring variables, we could do multiple variables. So x, y, colon equal 42, comma something. So let's just get a visual on that. So we saw we could do x colon equal 42. And we could do y comma z colon equal 43 some string, right? And we also saw var w int, and we could do w equals 40, right? And then we could print line all that right here, w, x, y, z, right? And print line takes a variadic number of arguments, so we could pass those all in. Print line also returns the number of bytes written and an error, which we could also assign, and then we could print line those. And if I run this now, I'm going to get an error. Because I didn't use E. Well, I could use E, or I could put in an underscore, which means I know I'm supposed to do something with that, and I'm choosing not to. I'm not just blindly ignoring it. I know something's supposed to be done with it, and that's just throwing it into a deep, dark black hole, disappear it. I don't have to deal with it. And so, non-declaration statement outside function body. Var w equals 40. You mean I can't do that? That's weird. Let's see the error for E. I have to do it like that. I can't do outside like that. I thought I'd be able to do that. That's funny. Learn something new. So E is declared and not used. Let me throw E away. So that's something you didn't see. Seen that? So we saw that. We saw how to create functions. whatever you want to call it. And you need those parens to execute it. And we saw how to pass, write a function that takes parameters. And takes multiple parameters. And then we saw about documentation at golang.org, the official website. There's the Golang specification. There's effective Go. There's the Golang FAQ. And then we also saw how to read the standard library. You could do it at golang.org. I recommend godoc.org. And godoc.org has the standard library and third-party packages. And we saw how functions are declared. Functions are declared func, receiver, identifier, params, returns, code. And we saw, oh, hey, when we have receivers, those are methods attached to a type. And so we were looking at text template package. And the text template package, we look at the index. Right? When we parse files or parse glob, we get a pointer to a template. We then have all these methods here, right? Which we can use right here. Everything, all these receivers mean that whatever value we get back, we assign it to a variable, and it's going to be a type pointer to a template, so that value now has all of these methods available to it, like execute or execute template. So we saw how to parse files and then execute those files, and we saw how to pass data into them, because when we execute, it says, hey, give me data of any type. Empty interface means any type. So give it any data of any type. We have 50 minutes left in class. Goes till 10:20. It's a long class, man. 5:30 to 10:20. What I want to do is I want to give you an assignment. I'm going to show you how to set up your computer. We're going to do that tonight because I went into stuff I didn't think I was going to go into. I thought I was just going to be showing you language stuff at the playground tonight. But with everything I showed you, I need you to use it. Otherwise, you're going to lose it. So I'm going to help you get your computer set up. And those of you who don't have computers, I think you're smart enough to, when you watch this, you'll get it at home. And if not, I think you're quick enough, whatever, next week. If you don't do the assignments this week, you've got a lot of it. So that's what we'll do for the rest of the night. So you can then, I'm going to have you parse files and basically just take whatever code I have there and create some files and parse them and execute them. That's it. And then pretty soon, just give you a preview of what's coming. Right here, we're doing all of this different data structures. And then we're going to do a HTTP server. Right, here's my handle func and my listen and serve on port 8080. So I say catch different things that come in at different RESTful routes on my server. If you go to mcleods.com/dog, I'm going to run function bar. If you go to any other route, I'm going to run foo. And then I execute different code. Well, instead of just printing stuff out, let me execute different templates and write them to the response. Right? Response writer takes a request and response writer from package net HTTP. Pretty cool. So that'll be next week. We'll set up a server. We'll start serving pages. execute our HTML and serve it. We'll do it at localhost, but then, hey, it's easy enough to deploy it. Let's take a 5-minute break, and then we'll get machine set up.